Welcome to our communication system course. In the last class, we have seen the multi-tone AM modulation. Now, today we will see single tone AM modulation. For today, single tone we will talk about single tone AM amplitude modulation. AM represent for single AM amplitude. Single tone means a single frequency. We are talking about single frequency. Okay, single frequency, then we have to write first the message signal maybe SMT, so or MT is equal to AM cos 2 pi FMT. This is our message signal. This is basically we have only single frequency, then it is called single tone signal. This is also called single tone signal. Okay, now what will be the amplitude modulated signal, that is SMT. SMT will be what SMT will be we have already seen in the case of multitone. Similarly, we can write the formula for single tone AM, and that will be AC 1 plus KA MT cos 2 pi FCT. Okay, am I right? And we are just what we are doing, just putting the value of MT, then we can write AC into 1 plus KA MT sorry AM cos 2 pi FMT into cos 2 pi FCT. Now we are just expanding more by removing the brackets, and then we can write AC cos 2 pi FCT plus is KA AM AC cos 2 pi Fm T cos 2 pi FCT. Okay, now we can write here K A M. This is described by a new factor that is called mu, which is modulation index. Why modulation index term is very famous? Because of due to mu, we can define either our modulated signal is under modulated or critical modulated or over modulated. This is defined by this term mu. If mu is less than 1, then modulated signal is called under modulated. If mu is equal to 1, then it is called critical modulated, and if mu is greater than 1, then it is called over modulated. Okay, what does this mean? Under modulated, critical modulated, over modulated. It is very easy to understand critical these three terms. Under means what? Under means if you this our message signal is suppose like that, this is our message signal, this is T, this is our MT. Okay, and our carrier signal is also, I am drawing, suppose our carrier signal is this one is the carrier signal. Then our if mu is less than 1, then what will happen? If mu is less than 1, we can draw this signal here, and also we can draw the inverted of that one, so on. Okay, I'm just continuing for the minus T for plus T, and what will be the and just I'm drawing here envelope. Okay, and our final signal is that I'm drawing the final signal that is from red one here. This is the our for mu less than 1. What will happen when mu is equal to 1? When mu is equal to 1, then it will touch like that one. This is our empty, and this is, and our modulated signal will be like that one. I'm just drawing sinusoidal signal. I'm not drawing very smoothly. Actually, this is our modulated signal, and it is just critical to going. It is just critical to demodulate it. If more than one, if it is more than one, if mu is more than one, then we cannot demodulate it, because then signal will be destructed. Modulated signal will be destructed, and we cannot, this is the envelope by which we can in the case of demodulation, we know that there is only low pass filter to use for demodulated, and and low pass filter, what low pass filter will do, they will just follow the envelope and we will get the output. If we cross the x-axis, this x-axis, then we will lost the message signal. Okay, that's why we have to keep mu less than 1. I hope what I am trying to say is clear, that for demodulation we have to keep mu less than 1. Okay, fine. Now we will go further by calculating power of AM, power of single tone AM. We are talking about single tone AM, na? Single tone AM. If we will talk about single tone AM, first we have to write the expression what we have written before. We have just SMT. SMT is what we have written, AC cos 2 pi FCT, sorry, cos 2 pi FCT plus AC mu AC. I am writing here mu AC. Okay, mu AC cos 2 pi FMT plus sorry, cos 2 pi FCT. Okay, this is our carrier signal, and this is basically carrier as well as our message signal. And if you draw the draw the draw in frequency domain, we can draw like that, that we have just this is our F, this is SMF, and this is for FC and minus FC. And what will be the power amplitude of that one? That is AC by 2, na? This is AC by 2. Okay, and what will happen about that? We can draw the the in the frequency domain, we have just two arrow, and this is one called upper sideband, and this is called lower sideband. And what will the amplitude will be, that one? Mu AC by 2, mu AC by 2. And what will that one? Mu AC by 2. Amplitude will be same, and there is a mirror image at negative frequency also. It will be at FC plus FM, and it will be at FC minus FM. And similarly here, this is basically lower sideband here, the mirror image of that one, and this is basically upper sideband, mirror image of that one, and this is minus FC plus FM, and this is minus FC minus FM. Okay, and amplitude will be remain same, mu AC by 2 and mu AC by 2. if you will talk about bandwidth, then bandwidth will be that one, then fc plus fm minus fc minus fm, that will be 2 fm, bandwidth will be 2 fm. If we will talk about power, then we have to add the left side of right side of frequency and as well as left side of frequency power, both power we have to add on. Then if then power of am will be what, am power will be, how will, what will be the power will be just AC by 2 whole square. Okay, actually first before going to calculate power, first we have to define, suppose we have a cos 2 pi ft. Okay, then sorry, Vm, so like I'm writing here Vm, then P, we have to define two types of power, that is PDC and PAC. If you talk about PDC, then what will be the reply, what will be the answer, that is Vm square by 2. And what will be the PAC? PAC will be defined by the resistance what we are using, that Vrms whole square divided by R. Okay, and what will be the Vrms? Vrms is basically Vm by root 2. It means PAC is basically Vm square by 2R. Okay, for this one. Okay, clear? Then without going into the detail of this one, we can just calculate the power from this expression also. Okay, if you want to calculate by this one, we can also I will come later at this graph also, how we are calculating the power, but just adding all the power and all these three components plus these three components, total power we are adding. And how can we calculate by just whole square by 2 and and by 2 will give us the power of Am. Okay, just I am using this expression, okay, actually right now. Then the power of AC, basically I am AC power is I am calculating AC power. Then what will be the answer, that here our expression is amplitude is AC, then we can write here AC square by 2R. Okay, okay, clear? And sorry, and this is mu AC, and actually we can expand it, cos 2 mu AC by 2 cos 2 pi fm plus fc plus fm and fc minus fm, 2 cos, actually we know that 2 cos A into cos B is equal to cos A plus B plus cos A minus B. We know that one, na? We use this type of formula by divide by 2 and multiply by 2, and then we have to use this formula. Then we have mu AC by 2 plus mu AC by 2. Actually this one will be the, what will be the answer, mu AC by 2 cos 2 pi fc plus fm into t plus mu AC by 2 cos 2 pi fc minus fm by 2 fm into t. Then for this one we can write mu AC by 2 whole square into 1 by 2r, 1 by 2r. Okay, plus mu AC by 2 whole square into 1 by 2r, and we can common out AC square, AC square, AC square by 2r we can take in common. Then what will be the what will be, first we have to add this one, so this is 1 plus, then it will be mu AC, sorry, mu square, AC will be, AC square is already common out, then it will be 2. I hope it is clear, na? Because actually this is for 2r is already common out, and we are just adding here, then it what will be the summation of these two terms? Mu AC by 2 whole square into 1 by r. This will be the summation of these two terms. And what we have done, 2 r is common, and this is actually 4, then 2 is already common out, then here we have left with 2 term only. This is our PAC expression. Okay, now LSB power is what? LSB power is this one, and USB power is this one. LSB power, if you talk about power of LSB, is what? Mu AC whole square divided by 2 to the 8 r. Okay, and we can write it as, and what is power of USBs is same as mu AC by whole square by 8 r. Okay, it is clear na? And if we want to write it in terms of PC or PC, that is, this is PC. If we want to write it in the terms of PC, then we can write it as this is mu square, and this is actually 2 will be is 4 will be left out, PC into mu square by 4, and same for this one, PC mu square by 4. Today this is all about, and next in the next class we will continue by calculating efficiency and so on. Today we will stopping here, and I hope everything is clear in this lecture. If you have any doubt, then you can ask me in the chat box. I will try to reply all the questions. Okay, thank you for watching.